Alright, so what we're going to be doing today is we're learning a new section. We are learning how to factor another trinomial, but in this case our trinomial has a number in front. I'm going to show you Alright, I'm going to show you an example of this. So notice all our previous, right? Here's your warm-up, but all of our previous problems look like this, right? Notice how we do not have a number out in front, right? We have nothing here. Usually we can just imagine it's a 1. That's all the problems that we've done previously, but now we're going to be working with something that looks like this. Looks like, what is the difference is now it has a number out in front, and we actually do have to handle this a little differently than what we're used to. So let's read our notes, okay? In the previous lesson, you factored trinomials in the form of x squared plus bx plus c. Now you will factor trinomials in the form ax squared plus bx plus c. Remember, a, b, and c means numbers, right? 3, okay. 3, -2, and -8, or in this case, 1, 4, and 32, were all a, b, and c, okay? When you multiplied, remember when we had to do FOIL, right? 2 sets of binomials, we had to FOIL. When you FOIL out 3x and 2x, we actually get a 6x squared. So this is how, okay, we develop a trinomial that has a coefficient out in front. So we are essentially reverse FOILing, okay? This is our FOIL, so we go from here to get a trinomial. We're going to reverse FOIL to get back into 2 sets of parentheses. So there are 2 methods. Okay, I'm going to show you one method. Okay, this is method 1. This is Miss Urban's preferred method. However, there is a method 2. And I'm going to tell you the difference between the 2 methods. This method that I'm going to show you in the video, this is for people that enjoy factor trinomials, what we've been doing for the last week. So it looks like something like this, where you have to find 2 numbers that add to get me 5, but multiply to get me 6, and right, we can just do it this way. No, actually, no, we can't. Just kidding. Let's try this again. This one, sorry, that adds to get me 5, but multiplies to get me 6, right? So it would be something similar to this. For method 2, I'm going to post a video, a YouTube video, because I'm not going to try to explain method 2. Method 2 is not something that I prefer. It's not something that I really think would benefit a lot of students, but sometimes method 2 actually helps a little bit more, and that's for people who enjoy factor by grouping. And if you can't remember factor by grouping, it's something similar to like this, where you have x cubed plus x squared minus 3x, plus 8, right? Remember, factor by grouping has 4 pieces, and you have to put parentheses around the first 2. You put parentheses around the last 2, and then you factor out what's common here. In this case, it would be x squared. You factor out what's common here, which in this case is nothing. So you would just do plus 1. And then you figure out your leftovers and blah, 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 blah. Okay. I don't particularly like this method. I prefer this method. I like factor by trinomials. So for problems, okay, if you like factor by trinomials, you're going to prefer swing method, and that's what I'm going to show you right now. So let's practice with doing these problems. So here's our problem. We have 3x squared minus 2x minus 8. Here's our first problem. And here are the steps to the swing method. We're only ever going to use a swing method when there's a coefficient. Oof, come on. When there's a coefficient, right? When a equals a number other than 1. Really can't spell today. Other than 1. My handwriting's horrible today. All right, so something like this, right? Notice how we have a number out in front. Swing method tells us to swing the first coefficient to the back and multiply it. So let's use a different color. We're going to take this number right here, and we're going to swing it to the back. Okay, so now our new problem is going to look like this. X squared minus 2x minus 24. Why? We took this 3 and we multiplied it to the back number, right? Minus 8. So we did 3 times minus 8, and we got our last piece as minus 24. And because we took that 3 and moved it, we only had left x squared, so I leave my x squared and my minus 2 the same. Okay, check. 2. Treat this like previous problems, factoring trinomial. So notice how it looks. It looks just like the problems we've been working on in the last week. So we are going to treat it just like it. We're going to find two numbers that multiply to get me negative 24 and that add to get me negative 2. So we start thinking of multiples of 24. Well, multiples of negative 24 mean that one number has to be positive and one number has to be negative. So let's start thinking of some answers, right? Let's do positive 1, negative 24, and let's try the opposite. Minus 1, positive 24. We're just going to start naming numbers. Okay, so positive 2, negative 12, negative 2, positive 12, and we just keep going. I think that's it. And then we have to figure out which one of these adds to get me a negative 2. So which one adds to get me a negative 2? So let's just start going down the list. Right. So this winner right here, multiplies to get me negative 24, but then adds to get me a negative 2. So we know this one's the winner. So we write it in the normal form that we're supposed to have, which means 2 sets of parentheses. I'm going to erase this just for space. Right? You can always pause the video if you need to still see this, but I would hope at this point you know how to complete problems like this. So we write it in the form of this, right? We write x plus 4 and x minus 6, and if we were to check our work, we get right back to this answer. But remember, this is not our starting point. This was our starting point, right? So we want to try to get back to that. So step 3 of swing method. Once you get your answer in that form, 2 sets of parentheses, you need to remember to divide by your previously swung number. What this is saying. Remember, we multiplied the back by 3. We can't just forget that we multiplied or moved that 3. Excuse me, we now need to divide by 3. We need to remember because we multiplied by 3. We now need to divide by 3. And this says, if you cannot easily divide, swing that number to the back. Let me change that because I don't really like the way that says. No, I can't change it, can I? Okay. That's fine. It's just not worded good. So notice in these problems, right? I'm going to try to divide this, but notice how it doesn't really get divided too well, right? 4/3 is not a pretty number. It comes out to be like 1.25, and that's not a pretty number. So if it doesn't come out to be a nice whole number, what step 4 is telling us is to swing your denominator, right? Swing the denominator, that's what I meant to write, to the front. And we're going to swing this to the front. So this becomes 3x plus 4. Now, notice for this one, negative 6 divided by 3 does come out to be a nice number. Because it comes out to be a nice whole number, we can just keep it like that. Just simplify that answer and write it right there. So again, I'm going to try to reemphasize this last step, okay? We had x plus 4, we had x minus 6. We originally multiplied by 3, we swung that 3 over here. So we need to do the opposite, which means we need to divide by 3. When we divide both sets of number by 3, if it comes out to be a nice whole even number, we're going to keep it, right? So x minus 2, because negative 6 divided by 3 gets me negative 2. But if it doesn't come out to be a nice pretty number, notice how this one we get 4/3, and 4/3 is not a pretty number. You're going to take your denominator and you're going to swing it to the front of your variable. So we get 3x plus 4. Okay, this is our final answer, even though you might not believe it. This is our final answer. And how can we know that this is our final answer? Let's check our work. Okay, always try checking by foiling. So let's do it. 3x squared times x gets me 3x squared. Oh, 3x times negative 2 gets me negative 6x. 4 times x gets me 4x. Last 4 times negative 2 gets me negative 8. We can combine our middles, so we get 3x squared minus 2x minus 8. And does that get me my original problem? It does. So we know that this has to be the correct answer. Kind of crazy, right? Well, don't you worry. We are going to do a ton of problems. It's very time consuming. That's why I'm not going to give you too many problems to be doing today, but it is something that you need to make sure that you practice with. You can't just expect to get it the first time. Okay, we're going to try this problem next. Okay, so let me use a different color. Remember, swing method. Swing the first coefficient to the back and multiply it. So we're going to take this coefficient, we're going to swing it to the back and multiply it. So my new problem is going to read x squared plus 17x, in this case minus 42. Okay, right, 2 times negative 21. So now, treat this, step 2, treat this like the previous problems we've been doing, factoring trinomials. So we need to find two numbers that multiply to get me negative 42, but that add to get me 17. So with multiplying to get a negative 42, we know that we have to have one negative and one positive. So we start guessing. Okay, and I'm going to skip this step together because I already know this, and if you do all these steps, you will also become, you will easily be able to figure out what two numbers, right? Multiply to get me negative 42, but then add to get me 17, and you will know that it is, what is it again? I had it on the tip of my tongue. 42. Maybe I should be doing this. Yeah, you know what, let's do this problem out. I don't know what I'm thinking. Oh, that was my mistake. Notice my mistake. My mistake was that I made this negative, and it's supposed to be a positive. So let's restart the problem altogether, right? Okay. Always, if you mess something up, just start back from the beginning. Let's start all over again. Ready? Here's our next problem. 2x squared plus 17x plus 21. Step 1, swing the first coefficient to the back and multiply it. So we're going to take this coefficient and we're going to swing it to the back. So my new equation looks like this. X squared plus 17x plus 42. That makes more sense now. And step 2, treat this like a previous problem, factoring trinomials. So we're going to find two numbers that multiply to get me 42, but then also add to get me 17. So to get us positive, multiplication of a positive 42, and I add to get me a positive 17. Both numbers have to be positive. So we're going to start making guesses. Positive 1, positive 42, and I'm actually going to do them all out just for the heck of it, so I don't think I'm going crazy. 2 and 21, 3 and 14, 4 is not a multiple of 42. See, even Miss Urban makes mistakes. 5, 6, is 6 go into it? Yep, 6 does go into it. So, plus 6 plus 7, right? They multiply to get me 42. So these are all the multiples of 42. Which one of these adds to get me 17? So I have to go by each problem and say nope, nope, yes, no. So we know that this one's a winner. So we get x plus 3 and x plus 14. So for space, I'm going to erase this. Okay, you do not have to erase anything on your paper. You should be showing me all the work. So we finished step 2. Now, once you get the answer in 2 sets of parentheses, you need to remember to divide by the previously swung number. So remember, we previously swung the 2 in the back to be multiplied. So we need to remember now we need to divide by 2. If we originally multiplied by 2, we need now to divide by 2. If you cannot easily divide, swing the denominator. Okay, swing the denominator back into the front. So notice this problem, 3 halves, does not come out to be a nice easy number. We cannot write 1.5. That's not what I want, right? No, 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 no. Okay, so what we're going to do is we're going to take this denominator and we're going to swing it in front. So it becomes 2x plus 3. Okay, notice how I did that. 3 over 2 is not an acceptable number, so we need to take this denominator and swing it in front of our variable. So it becomes 2x plus 3. This one actually does simplify though, right? 14 divided by 2 does get me a nice pretty number. It's 7. So we can simplify that one. You should not swing that 2 in front. All right, so we think that this is our final answer. Oof, we think this is our final answer, and how can we know? We're going to check our work. How we're going to check our work? We're going to FOIL. Oh, really can't spell today. Okay, so let's try it. 2x times x gets me 2x squared. 2x times 7 gets me 14x. 3 times x gets me 3x, and 3 times 7 gets me 21. Okay, combine your middles, and we get a final answer of 2x squared plus 17x plus 21. Is that our original problem? Yes, it is, so we know that this has to be the correct answer. Okay, let's try more problems. Okay, let's try another one. Oh, I like this one. All right, let's do this one. So 6x squared plus 11x plus 4. Okay, so step 1. Okay, swing the first coefficient to the back and multiply it. So we're going to take this 6, your first coefficient, and we're going to swing it to the back to multiply. So this whole equation now looks like this. X squared plus 11x plus 24. Now, treat this like a problem that we've previously done and find 2 numbers that multiply to get me 24, but add to get me 11. Okay, so start naming multiples of 24. We can name a bunch of them. I'm just going to name a few. Let's go 1 and 24. Let's go 12 and 2. And let's go 3 and 8. 6 and 4. And I think that that's it. Yeah. Which one of these adds to get me 11? Well, we'll find out. Our lovely solution is right here. 3 and 8. So we write in parentheses x plus 3 and x plus 8. So step 2. Once you get it in two sets of parentheses, you need to remember to divide by your originally swung number. Oi. So we are going to divide by 6. Now, here's why I like this problem, because this problem is presenting a new problem, a new issue, I should say. Notice how neither one of these reduce to be a nice whole number. It's okay, sometimes this happens. So what you're going to do is always try to reduce before you swing. And yes, I just wrote before. It's late. Okay, so what we're going to do is reduce first. So instead of doing x plus 3/6, can't 3/6 reduce to 1/2? And can't x plus 8/6 reduce to be x plus 4/3, right? Reducing fractions, right? We reduce the fractions, and then we still realize that you can't divide. You can't easily get a whole number from this. So it's okay. We're going to swing both denominators. We're going to swing this 2. Whoa, you're not going to take it. We're going to swing it out in front of this one, and we're going to take this denominator, and we're going to swing it out in front of this one. So we get parentheses 2x plus 1, and we get 3x plus 4. Okay, sometimes you only have to swing one number. Sometimes you have to swing both numbers. It's okay. Okay. We think that this is our final answer, but let's check. Okay. Check our answer. By, how do we check? We check by FOIL. You're going to be so tired of FOIL by the end of the year. So 2x squared times 3x squared gets me 6x squared. 2x times 4 gets me 8x. 1 times 3x gets me 3x. And 1 times 4 gets me a positive 4. Combine middles, and I get 6x squared plus 11x plus 4. And is that my original question, original problem? Yes, it is. So we know this has to be the correct answer. Okay, so this is just dipping our toes into the swing method, right? We're not going to get into too many hard problems. Believe me, these problems get much, much, much harder. But this is just kind of stepping our toes into it. So your classwork, your homework for today is only going to be doing 3 of these problems just to dip your toes in.